Welcome to Soldier's Heart. Today we're talking about the incredible and incredibly slow forces that are constantly sculpting our world. From the tallest mountains right down to the ground under our feet, there's this powerful process at work, just breaking down solid rock. So let's get into how it all happens. Alright, so to really get a handle on these forces, we're going to start with a bit of a geologic mystery. And for that, we are looking at one of the oldest mountain ranges on the entire planet, the Aravalli Hills in India. Picture millions and millions of years ago, the Aravalli Hills were absolutely colossal. We're talking jagged, towering peaks that could rival any mighty range we see today. But if you go look at them now, they're these worn down, gentle hills. They're really just shadows of what they used to be. So that begs a pretty huge question, right? What force out there is so powerful, so persistent, that it can literally grind down an entire mountain range, grain by grain, over millions of years? Well, the answer is a process called weathering. It's this slow, relentless breakdown of rocks, soil, and minerals that happens right on the Earth's surface. It doesn't happen overnight, of course, but you give it a few million years and it can move mountains by literally tearing them apart, piece by piece, Now, here's the key thing to remember about weathering. It's what we call an in situ process, which is just a fancy way of saying it happens right there on site. This is all about the breaking down, not the carrying away. Think of it as the first step that weakens and fractures the rock, getting it ready for whatever comes next. So weathering has a few different tools in its sculpting kit. Let's dive into the first one, physical weathering. It's all about pure mechanical force. It's basically nature's brute force method for breaking big rocks into smaller rocks. One of the most powerful forces is actually something we experience every single temperature change. In hot, dry climates, rocks heat up and expand during the day. Then at night, they cool down and shrink. This constant cycle of expanding and contracting creates this immense stress, and eventually the rock just cracks. And water, water plays a huge role in a process called frost wedging, So water seeps into a crack that's already there. When night falls in the temperature, that water freezes and it expands by about 500 Joule. This expansion acts like a super powerful wedge, forcing the crack wider and wider every single time it freezes and thaws. So over long periods of time, all this stress on the surface from temperature changes leads to this really fascinating process called exfoliation. Basically, the outer layers of the rock are getting way more stressed out than the inside, causing them to weaken and just peel away. The result is that the rock's outer layers just flake off in these sheets, and it looks almost exactly like you're peeling the skin from an onion. It's the perfect analogy. Okay, so let's move to the next tool in the kit. This one's less about brute force and more about transformation. It's called chemical weathering. This is where the actual minerals that make up the rock get altered by chemical reactions, weakening it from the inside out. And, all that cracking from physical weathering, well, that just creates way more surface area for these chemical reactions to attack. A really key chemical process is oxidation, which is basically the exact same thing that causes metal to rust. When certain minerals inside a rock, especially iron, get exposed to oxygen, they go through this chemical change. Think of it like a recipe for making red soil. You start with ingredient number 1, a rock that has iron in it. Then you add ingredient number 2, oxygen and water. The result, the iron essentially rusts, forming iron oxide. And that's what gives so much of the world's soil that distinctive red color. Right? So we've got brute force, we've got chemical reactions, but there's a third kind of surprising force at play here. Life itself, this is called biological weathering, and it's how plants, animals, and even tiny microscopic organisms get in on the action of breaking down solid rock. And I know it sounds a little crazy, but the slow, persistent growth of a plant root can be unbelievably powerful. As a root works its way into some tiny crack looking for water, it just keeps growing thicker over time, and it can generate enough force to literally split solid rock apart. And it's not just big plants. Even teeny tiny organisms like lichens and mosses are sculptors. As they cling to a rock surface, they release these chemicals that create this acidic little microenvironment, and that slowly but surely dissolves the rock and eats away at its surface over time. Okay, so we've got cracking from physical forces, we've got changing from chemical reactions, and the non-stop impact of life. But so why does this slow motion destruction actually matter to us? Well, this is where it all comes together, and it's probably the most crucial point of this whole thing. All these weathering processes, the physical, the chemical, the biological, they are the first most essential step in creating one of our planet's most vital soil. I mean, let me put it this way. Weathering is what transforms barren solid rock into the tiny particles that, when you mix them with organic material, become the foundation for it. Without weathering, there'd be no soil, and without soil, there's no life on land as we know it. It's that fundamental, and that kind of leaves us with a final thought, doesn't it? This slow, relentless process of weathering is this powerful reminder that our planet is in a constant state of creation and destruction, just slowly but surely reshaping itself. It really makes you wonder if even the mightiest mountains can eventually be ground down to dust, and what on earth is truly permanent. Thank you.